So our objective is to understand how to calculate circumference and areas of circles. And in addition to doing that, you're also going to be given an area, and your job would be to find a missing piece. Okay? So use circumference or area of a circle to find. And what's the only thing that we can really find in a circle? What? A radius, right? And this comes out of lesson 11.5, so you can review there. So we actually don't have any theorems with the formulas. That's interesting. And that's because you should already know them. Huh. Then why did they give us formulas of things that we should have already known already? That's weird. Hold on. Okay, we'll move on. So the reason why we can't apply any formula that we've been talking about to circles is that circles aren't polygons. Okay, so that's a little note we're going to make to here. A circle is not a polygon, and in particular the reason why is it has no sides. It's a continuous curve, and so all the other formulas that we talked about had sides to them. All right, so vocab word coming up: circumference. Now, because a circle is not a polygon, we can't use the notion of perimeter with it because it doesn't have a perimeter, because a perimeter is counting up the lengths of the sides. There's no sides. So perimeter, or circumference, is like perimeter, but it applies only to circles. So it's the circle version of perimeter. So I'm going to use in quotations perimeter of a circle. Okay, so circumference is the perimeter of a circle. And again, we can't use that word technically with it because it has no sides, but it's just talking about the outer edge, which again, I can't even use that word because that evokes sides. It's the outer part of the circle, okay? And so we have two formulas for the circumference of a circle. And they are based on a radius, one of them is, and they're based on a diameter. So some people memorize one only, some people memorize a fact, and then they can interchange between the two. So the one that most people know is the one that uses a radius, which is what? 2 pi r. Okay, so where r is the radius, so I can't make a star of this, but you need to memorize that formula if you don't know it. Now, the second version of this would be using diameter. And what would be the formula if it just was knowing the diameter? It would be pi d, where d is the diameter. Now, you can memorize one of these and then note this fact. What's the relationship between a radius and a diameter? Rachel?
Two radii.
So 2 radii equals 1 diameter. And so some people, all they do is they memorize one formula and they know that relationship, and then they can substitute it in. So if one diameter is 2 radius, I can replace in the second formula the d with a 2r, and then I've got the 2 pi r. Okay, so it really doesn't matter. Now, again, what do you see that they both have? They both have pi. The formula for the area of a, I'll put them right here, of a circle. What's that formula? Pi r squared. So those are the two formulas you need to know. You can know the two versions of the same formula for circumference, or just memorize one and know the fact that it takes 2 radii to equal a diameter. But then you've got the area is going to be pi r squared. Okay, so again, the one thing that's consistent with all of those is our friend Mr. Pi. So let's do a vocab card on him. So that's the symbol. It's the Greek letter pi. That's how he gets his name. And it's actually spelled just pi, which, by the way, if you ever play Words with Friends, it's a great way to use up an I. Use pi all the time. Great way to use an I. Now, what is actually pi? This was Pythagoras, I believe, was the guy that did this one. He was studying the relationship of circles. So he was looking at their circumference, so string, and somehow measured it. And then he went to the diameter and measured that. And he looked at the relationship. Now, in math, when you look at a relationship, you do a comparison. And when you do a comparison, it's usually involving division. If you guys did I dress up for this Halloween? No. I wasn't a pumpkin this year? I think I was. Yeah, no. I was. You were schoolgirl. Yeah. No. I had this on the front of my pumpkin costume. On the back of my costume, I had this. And I was pumpkin pie, right? Okay. And that is the formula. Circumference equals pi times diameter. Okay? So I was just saying my front half and my back half mean the same thing, but I wrote the formula in a different way so that you could figure out, you had to think about me being pumpkin pie. So pi is just the ratio. This is the definition. Yeah, we'll get there. We'll get there. Ratio. Hey, at least you got there, right? Ratio of the circumference of a circle to the diameter. Okay. This value pi is true for all circles. So it doesn't matter how large, how small the circle is. When you compare the ratio of the circumference, or you have compare the circumference to the diameter of that circle, the number you get will be the same. Now, what do we know about pi? Pi is very irrational. He has no ending. He doesn't repeat so far that we know. I can't even remember how many digits they're up to. They have it in a computer, and every so often a new digit appears. People have contests memorizing as many digits as they can after the decimal points. People celebrate Pi Day not because they care about PI pie, they just want the PIE pie or donuts, anything that's circular. So it's kind of sad. It's a true thing about most holidays. It's not about what are you celebrating really, it's about what food do you get to eat, right? Okay. So the approximations that we use, since he is never ending, and the one that you guys have been using for the majority of your mathematical career is what? 3.14. The problem is, as you're getting higher level of math, you're also getting into, you're able to deal with more real world situations, and often that number is too rounded and it doesn't give us a real accurate answer, especially if you are dealing in science or biology or anything else and need to be as accurate as possible. actually more accurate, I think, is the fractional version, 22/7. Now, firemen actually use that. Why would firemen use pi in their job? Josiah?
So they know how big the hole should be when they go down the pole?
Nope. Nope. It's actually a much more life-saving reason. Shh. Yeah. Exactly. It has to do with knowing the diameter of the hose and what pressure or amount, because they kind of estimate how much water they're going to use based on the type of fire that they have. So they actually calculate using 22/7 to figure out the volume of water that they're going to need going through that hose. And if they try to put too much volume in too little of a time, yes, they can have issues with the hose. But again, it's all mathematical. So that's a job that uses mathematics in it, which you wouldn't think about. Yeah.
My neighbors a couple months ago, their garage caught on fire, and the firemen came, but they brought the wrong size hose, and they couldn't connect it to the thing, so they called the Costa Mesa Fire Department.
Yeah. That's kind of strange too, that you estimate what kind of fire it is. You can't possibly bring every single type of hose that you would need. So they kind of, and I never really thought about that before. And so, yeah, coming with the wrong hose, or what if they had the wrong fitting? And at that point, time is of the essence. So that's kind of scary. Now, some people go a little bit deeper, and they use this version, because that's 4 digits after the decimal point. But the one that I was told when I took a class, I don't know how many years ago, 10 years ago now, from a teacher who teaches in Fountain Valley, he said, and this is what he told me, so this is one I kind of go with, the most accurate one for us to use at this level is 3.14159. Now again, some of you have gotten into trouble in prior problems when you are rounding too soon. When do you get to round an answer? When do you get to round an answer? The final answer. So you do all the mathematics with the actual values, and it's only after all the mathematics have been performed that you round to the column they tell you to. So when you are pre-rounding, you're actually getting an answer that's overestimated. And I think some of you had that in that trig word problem portion of the test, where you rounded your trig value, and then you rounded your answer, and instead of it being, let's say, 147, you got 148 or 146. And the answer is supposed to be 147. So again, you have to be really cautious. You only round after you've done the math. Yes, ma'am?
So from now on, we're going to be using the 3.14159.
That's going to give you, read the book. The book will tell you specifically, use this one. If it doesn't tell you, then your default is 3.14159. Okay? Because if the book is telling you use 3.14, they're basing their rounding off of you using 3.14. So you do need to read at the problem. It oftentimes will tell you. So if it doesn't tell you, default to 3.14159. Okay? And then let's see. So here's the problem though. When I multiply by 3.14, by 22/7, by 3.1416, and 3.14159, I'm actually estimating all my answers. So multiplying by these approximations, that results in a rounded answer. So if you want to have an answer that's exact, so for exact answers, we don't use an approximation for pi. We leave the answer in terms of pi. So 2 pi is an exact answer. 6.28 is a rounded answer. Okay? Now, in certain situations, 2 pi is going to be meaningless. So there's times when you have to use an approximation, because you have to have an actual physical number in order to, let's say, deal with volume of the water coming through your hose, helping you figure out what hose is going to be the best hose for you to use for the amount of water you're going to need. Okay? So there are times when the approximations are good enough and there's times when the only acceptable answer is the exact one. That includes the pi. So let's do a couple examples. So our default is if you're told to approximate and they don't give you a value, use 3.14159. If they give you a value to use the approximation, then use what they tell you, okay? So directions, find circumference. And area of a circle with radius 6 centimeters. So when I'm solving the problem, I'm basing it on the information they give me. So if they give me the radius, I'm going to use the radius version of circumference. The area, I have no choice. There's only one formula. Okay? So I just plug numbers in. So I get C equals, now it does not tell me to approximate. So I'm going to leave my answer in terms of pi. 2 pi times 6 gives me a circumference of 12 pi centimeters. So the circumference is 12 pi centimeters. I have to make sure that I get a label if they give me one. For area, it's going to be pi times 6 centimeters squared. So that gives me 36 pi square centimeters. And remember, I write it as centimeters squared, but I read it as squared centimeters. Okay, and that's, if they're asking me for an answer and they don't tell me to approximate, I write it the exact answer and leave it in terms of pi. All right, let's do another one. Find the circumference of a circle if the area is 25 pi. So we have the formula for area of a circle is pi r squared, and then I plug numbers in where they belong. So A gets replaced with 25 pi. That equals pi r squared. I'm going to divide both sides by pi, and I'm going to use the metric property, and I get r squared equals 25. Now, when I put a square root symbol around a variable, technically plus or minus needs to go on the other side. However, we're talking about the length of something. So what kind of answer do I have to get? Positive. So I actually don't need to worry about the negative version. I only worry about the principal square root, which is the positive one. So I get that r equals 5. Now that's not the question they asked me. They asked me for the circumference. But now I have a radius and I can do that. So circumference is the 2 pi r. And I get 2 pi times 5. And I get the circumference is, 10 pi. Now this problem did not give me any labels, so I'm not going to have any labels. So that's the ultimate answer to this problem is circumference equals 10 pi. That's what you guys get to work on.